just have a quick look at, get an idea of what graphs of the exponential function. I use the word the exponential function to denote that it involves e, and your note uses the terminology the natural exponential. So natural exponential, the exponential, involve the number e. So y equals e to the x. What does that look like? X equals 0. Anything raised to the power of 0 will be equal to 1. And it is going to have that upward curve increasing dramatically the bigger value you make x. So that's y equals e to the x. Once again, we'll change pen to y equals e to the 2x. So what happens if we change that value? We're also going to start at the number 1, and we're actually going to go up steeper. So there's y equals 2x. As mentioned, they both go through the point 1 on the y-axis. And so as x gets larger, y gets larger as well. Y equals minus x. Y equals e to the minus x. Now, our first point is to look at what happens when x equals 0. So where it cuts the y-axis, e to the negative 0 is still 1. So it is going to go through the point 1. And as x gets bigger, don't forget e to the minus x is 1 over e to the x. So you can see that as x gets larger, 1 over this is going to get closer and closer to 0. So it won't be a straight line, it'll be a nice curve down, and it'll keep going out there. We've talked about p equals p0 e to the kt as being an exponential growth. If k is positive, it's going to look like this here. K will just make it go steeper, but we've already gone from 1 here to 2, and as k gets bigger, it'll get steeper and steeper. What effect does the p0 have on the graph? So if k is equal to, if t is equal to 0, so here's my t, and here is my p. If t is equal to 0, doesn't matter what value k is, 0 times that will be 0, so e to the power of 0 is 1. So all of that, when t is equal to 0, e to the power of 0 will be 1. And then you've just got to multiply 1 times p0. So it's actually going to start at that point there. And it's going to increase, nice steep curve going up like that. So that's the graph of p equals p0 e to the kt. And then if k is negative, another way to write that is p equals p0 e to the minus kt. So k being positive now, but just to give you an idea that what's going to look like if the exponent, if this is negative, we've already seen that when the power is negative, we actually have that sort of shape. The p0 once again means that instead of going through 1, it's going to go p0. So here's my graph of p0 e to the minus kt when this is decay. And this is growth. And you can see why that when t equals 0, the initial value is p0.